I want to take this opportunity to configure R1 with global IPv6 addresses based on the IPv6 addressing scheme we have in our topology. So if we look at the output of show IPv6 interface brief right now, we can see that gig 00 and gig 01 only have link local addresses right now. That's it. We want to assign the global addresses, the 2001:db8:1:A address and the 2001:db8:1:12 address. So over on R1 right now, we're going to go to global configuration mode, interface, gigabit Ethernet, 0/0. We're going to type in IPv6 address, and now we're going to specify our IPv6 prefix. So we're doing a static assignment right now of our addresses. I'm going to assign the entire address. So gig 00. If you notice the topology, it says it's 2001:db8:1:A. So we're going to start off with that. 2001:db8:1:A. And then we have to specify what? We're going to have to specify our interface portion as well here. So right now, this is just the prefix portion of it, the original prefix, the /64, so the first 64 bits. Now I'm going to assign the interface portion to it. So the interface portion in this case is just going to end up being 1. So in reality, my 64 bits end up being 0, all the way to the very last bit being 1. So when that breaks up into hexadecimal, it ends up being essentially just :1 here. That's going to end up being my address. And then I need to specify my prefix. So this is a /64. So this is telling the router interface the first 64 bits is essentially your network ID, and then the latter 64 bits is your interface ID or your host portion if you're looking at IPv4 terminology. And then we can go ahead and hit enter. It's as simple as that. So if we look at the output now of do show IPv6 interface brief, we'll see in this output that we have our global address assigned to the interface now. Let's go ahead and do the same thing to gigabit Ethernet 0/1. So interface gigabit Ethernet 0/1. And in this output, we'll type in IPv6 address 2001:db8:1:12:1, and it's a /64 as well there. So the output of show IPv6 interface brief is showing us our global address there as well. We can take a look at this also through the running config. So show run interface gigabit Ethernet 0/1. We'll see that our link local address is listed there. We'll see that our IPv6 global address is listed here. But what about taking a look at the output of show IPv6 interface gigabit Ethernet 0/1? When we look at this output, we'll see here that we are up. We'll see that IPv6 is enabled. As soon as you assign a link local address or a global address to an interface, IPv6 is enabled on that interface automatically. So there's no special command you have to type in. Even though there's a command called IPv6 enable, if you want to turn IPv6 on the interface without giving it an IPv6 address, then you use the command IPv6 enable. But in most cases, you're going to turn IPv6 on by giving your device an IPv6 address, and it turns it on automatically for you. You can see the link local address is listed right here. We have no virtual addresses right now. We have our global unicast address. So our global unicast address is 2001:db8:12:1, and that belongs to a specific network, a specific subnet, specific prefix, and that happens to be 2001:db8:1:12:/64. We've also joined some various groups. These are multicast groups that we've joined. Now, why do we join these multicast groups? Because there's no broadcasting with IPv6, right? Broadcasting is gone. So we have unicast, multicast, anycast. So everything that used to rely on broadcasting now has to rely on multicasting. So in order for multicasting to work, we have to join various multicast groups based on the services and features and protocols that we are running on the device. So the multicast groups are going to be special for contacting DHCPv6 servers, contacting routers, contacting other services. So that's what the various groups are for. Our MTU size is still the same because it's based on our physical interface. We can see some ICMP information here as well. And then neighbor discovery. Neighbor discovery is based on the fact that we need to figure out what? We need to figure out who our neighbors are. Now, why do I need to figure out who my neighbors are? Well, let's focus, for example, on this portion of our network right here, from R1 down to our PCs. So from R1 down to our PCs, what is that? Well, that's an Ethernet network. How do we communicate in our Ethernet networks? What do we need, right? We need frames. That's layer 2. And what goes in those frames? MAC addresses, a source MAC address and a destination MAC address. Well, with IPv4, we used what to do that? How do we figure out the MAC addresses? Well, the source MAC addresses are, so that's not a problem. But the destination MAC address, how do we figure out what the destination MAC address is that's going to go in a frame? We would ARP, right? ARP, Address Resolution Protocol. Well, that doesn't exist anymore with IPv6. It's gone. So since that is gone, what do we have in replace? We have the neighbor discovery process. So the neighbor discovery process using multicasting is going to be able to figure out who are the neighbors on that local link. So that's how you're going to figure out your IPv6 to MAC address mappings. So if PC1 wants to talk to PC2, PC1 is going to have to figure out the MAC address of PC2. And it's going to use the neighbor discovery process, which is based on ICMP for IPv6. Also, we can see here DAD. What's DAD? DAD. DAD is duplicate address detection. That's what that is. Duplicate address detection. Here's the reason why. With IPv6, we have the ability to generate our own IPv6 addresses. So since I have the ability to generate my own IPv6 address, I need a way to figure out if it's unique. Because if I create my own IPv6 address, it might be the same as somebody else's. It could be. The odds are very slim, but it could be. So what I need to do is I need to figure out if somebody else out there has the same address. And I use DAD, duplicate address detection, to do that. It's a very simple process. Essentially, I call out there like a ping to find out if somebody responds to my own address. So I send out my packet to that address. If somebody responds, that I know that somebody already has it. But if nobody responds, then I know nobody has that address and I can go ahead and use it. So that's DAD in a nutshell. So IPv6 global addresses can be assigned statically as we did right here, using the IPv6 address command, specifying the prefix portion, then the host portion or the interface portion, and followed up with your prefix itself.